The National Electrical Code, specifically Section 408, does not explicitly require switches and switchboards to have lockout capabilities. However, NFPA 79 Section 7.103 requires the operating handle of supply circuit disconnecting means to be capable of being locked only in the open or off position. It's important to note that this requirement is not specifically stated to apply to switches within switchboards. OSHA Standard 1910.147 permits the use of tagout procedures instead of lockout procedures if the energy isolating device is not capable of being locked out. Furthermore, OSHA Standard 1910.147 mandates that energy isolating devices installed after January 2, 1990 be designed to accept a lockout device. Understanding the implications of these regulations is crucial for maintaining a safe working environment. While a specific scenario might not technically violate the NEC or OSHA regulations, it may not align with best safety practices. The absence of a lockout provision on an upstream switch introduces a potential safety hazard. This is because the switch could be accidentally turned on while maintenance or repair work is being performed on the downstream equipment, such as an induction heating power supply. OSHA generally favors lockout procedures over tagout procedures, emphasizing the greater level of safety provided by physically preventing the energization of equipment. If the switchgear in question was installed after January 2, 1990, it may not meet OSHA's requirements for energy isolating devices to be lockable. Several recommended actions can enhance safety and ensure compliance. Firstly, install a lockable disconnect switch. This involves having a qualified electrician install a lockable switch in the upstream switchboard. This provides a secure means of isolating the induction heating power supply or any other equipment requiring maintenance. Secondly, implement a comprehensive lockout tagout procedure. Develop and enforce a clear and specific lockout tagout procedure for all equipment repairs and replacements. This procedure should outline the steps required to safely de-energize equipment, apply lockout devices, and verify the isolation of energy sources. Thirdly, provide thorough employee training. Train all employees on the importance of lockout tagout procedures and how to properly perform them. Training should cover the identification of energy sources, the use of lockout devices, and the verification of energy isolation. And lastly, conduct regular inspections. Regularly inspect lockout tagout systems to ensure they are in good condition and functioning properly. Inspections should verify the availability of necessary equipment, the proper application of procedures, and the effectiveness of training programs. Now let's delve deeper into the technical aspects of lockout tagout procedures and the relevant electrical codes. When dealing with electrical systems, understanding the specific requirements of the National Electrical Code, or NEC, is paramount. While the NEC does not explicitly mandate lockable disconnects for all switchboard applications, it provides a framework for safe electrical installations and maintenance practices. The key is to interpret and apply the code in conjunction with other applicable standards such as NFPA 79 and OSHA regulations. The NEC addresses various aspects of electrical safety, including overcurrent protection, grounding, and wiring methods. These provisions indirectly contribute to the overall safety of electrical systems and support the implementation of effective lockout tagout procedures. For example, proper grounding ensures that fault currents are safely diverted, minimizing the risk of electric shock. Similarly, appropriate overcurrent protection devices, such as circuit breakers and fuses, protect equipment and personnel from overloads and short circuits. When planning a lockout tagout procedure, it's essential to identify all potential energy sources that could energize the equipment being worked on. This includes not only the main electrical supply but also any auxiliary power sources such as control circuits, backup generators, and stored energy devices like capacitors. Once all energy sources have been identified, the next step is to isolate them by disconnecting or de-energizing the relevant circuits and equipment. This may involve opening circuit breakers, disconnecting switches, or removing fuses. It's crucial to verify that the equipment is indeed de-energized before proceeding with any maintenance or repair work. This can be accomplished by using a voltmeter to measure the voltage at various points in the circuit. After verifying that the equipment is de-energized, lockout devices should be applied to prevent the accidental re-energization of the equipment. Lockout devices are typically padlocks or other types of physical barriers that are attached to the disconnecting means, preventing them from being operated. Each authorized employee who is working on the equipment should attach their own lockout device, ensuring that the equipment cannot be re-energized until all workers have completed their tasks and removed their locks. In addition to lockout devices, tagout devices may also be used. Tagout devices are warning tags that are attached to the disconnecting means, indicating that the equipment is out of service and should not be energized. Tagout devices are typically used in conjunction with lockout devices, providing an additional layer of safety. However, tagout devices should not be used as a substitute for lockout devices whenever lockout is possible. Once lockout tagout procedures have been completed, it's important to test the equipment to ensure that it is properly energized. This can be accomplished by attempting to start the equipment or by using a voltmeter to measure the voltage at various points in the circuit. If the equipment is still energized, the lockout tagout procedures should be reviewed and corrected. After the maintenance or repair work has been completed, the lockout tagout devices can be removed and the equipment can be re-energized. Before removing the lockout tagout devices, it's important to ensure that all workers are clear of the equipment and that all tools and materials have been removed. The equipment should then be tested to ensure that it is operating properly. In addition to the technical aspects of lockout tagout procedures, it's also important to consider the human factors involved. Lockout tagout procedures are only effective if they are followed correctly by all employees. Therefore, it's essential to provide thorough training to all employees on the importance of lockout tagout procedures and how to properly perform them. Training should cover the identification of energy sources, the use of lockout devices, and the verification of energy isolation. It's also important to regularly review and update lockout tagout procedures to ensure that they are effective and up-to-date. This may involve conducting periodic audits of lockout tagout procedures to identify any areas for improvement. Another important consideration is the selection of appropriate lockout tagout devices. Lockout tagout devices should be durable, reliable, and easy to use. They should also be compatible with the equipment being locked out or tagged out. For example, lockout devices should be sized appropriately for the disconnecting means and should be made of materials that are resistant to corrosion and wear. Tagout devices should be highly visible and should be made of materials that are resistant to tearing and fading. When selecting lockout tagout devices, it's important to consider the specific hazards involved in the work being performed. For example, if the work involves exposure to hazardous chemicals, the lockout tagout devices should be resistant to those chemicals. Similarly, if the work involves exposure to extreme temperatures, the lockout tagout devices should be resistant to those temperatures. Proper maintenance of lockout tagout devices is also essential. Lockout tagout devices should be inspected regularly for damage or wear. Damaged or worn lockout tagout devices should be replaced immediately. Lockout tagout devices should also be stored in a safe and secure location when not in use. The specific requirements for lockout tagout procedures may vary depending on the industry and the type of equipment being worked on. However, the basic principles of lockout tagout remain the same. By following these principles, employers can create a safe working environment for their employees and prevent accidents caused by the accidental re-energization of equipment. It's crucial to remember that lockout tagout is not just a set of procedures, but a safety culture that must be embraced by all employees. A strong safety culture promotes a proactive approach to safety, where employees are encouraged to identify and report hazards and to take steps to prevent accidents. A strong safety culture also fosters a sense of shared responsibility for safety, where all employees are accountable for their own safety and the safety of their coworkers. To cultivate a strong safety culture, employers should provide ongoing training and education to their employees on safety topics. They should also create opportunities for employees to participate in safety activities such as safety committees and safety audits. Furthermore, employers should recognize and reward employees who demonstrate a commitment to safety. In conclusion, While the NEC may not explicitly require lockable disconnects for all switchboard applications, adhering to NFPA 79 and OSHA regulations, along with implementing robust lockout tagout procedures, is crucial for ensuring worker safety. By prioritizing safety and fostering a strong safety culture, employers can create a work environment where accidents are minimized and employees are protected from harm.